Hey everyone, and welcome to The Explainer. Today, we're diving into a serious reality check on literally the most famous climate goal in modern history. If you've been following global news even a little bit, you absolutely know this target. But honestly, the recent scientific consensus is telling a pretty tough truth about where we actually stand right now. Let's get into it. Okay, 1.5 degrees Celsius. We're gonna anchor this entire explainer right here on this specific number. This is the critical threshold that sits at the absolute heart of the 2015 Paris Agreement. It's universally recognized as the boundary line. You know, the threshold where if we cross it, climate risks become incredibly dangerous for our ecosystems, our economies, and, well, us. But here's the reality check. That limit, it is now extremely difficult to maintain. In fact, without what scientists call a temporary overshoot, it's effectively out of reach. So here's our roadmap for today. We'll start with the 1.5 degree goal, then look at our current climate reality, the consequences of overshoot, why action fell short, and finally, what we can still do. Don't worry, we're going to pivot to some practical solutions at the end. All right, section 1, the 1.5 degree goal and where this target actually came from. When scientists and policymakers talk about the 1.5 degree limit, they specifically mean keeping the global average temperature increase below 1.5 degrees Celsius compared to pre-industrial levels. And by that, we're talking about the baseline years from 1850 to 1900. Now, this threshold wasn't just pulled out of thin air, right? It's based on decades of rigorous IPCC research. And what that research shows is that climate risks increase non-linearly, meaning the jump from 1.5 to 2 degrees isn't just a tiny bit worse, it is exponentially worse. Okay, moving to section 2, our current climate reality, or basically, where we stand today. I kind of need to hit you with the hard facts right up front here. According to recent global data from NASA, NOAA, and Copernicus, Earth has already warmed by roughly 1.2 to 1.3 degrees Celsius above those pre-industrial levels. Think about that. The last decade has literally been the warmest in recorded history. Actually, we've even had a few individual years recently that briefly touched or exceeded 1.5 degree anomalies. So we are uncomfortably close to that ceiling right now. And the underlying engine driving this whole upward trend? It's staggering. Carbon dioxide concentrations have now blown past 420 parts per million. To put that into perspective for a second, that is the highest level of CO2 in our atmosphere in at least 2 million years. 2 million. And look, these aren't just temporary blips. This is a long-term, aggressive upward trend driven directly by human greenhouse gas emissions. So how much are we actually adding to that mix? Well, humanity is currently pumping out roughly 37 to 40 gigatons of CO2 into the atmosphere every single year. Our global fossil fuel consumption just hasn't dropped fast enough. And this massive, ongoing annual addition directly feeds into a huge issue that scientists call the carbon budget problem. The best way to think about this carbon budget is like a bank account. The IPCC estimates that to have just a 50-50 shot, a literal coin flip, of staying under 1.5 degrees, we can only emit a strictly limited amount of additional CO2. That consumed chunk is massive. And at our current burn rate of around 40 gigatons a year, that tiny remaining sliver of our budget is going to be completely wiped out within just a few years to a decade. Section 3, the consequences of overshoot. Let's look at what actually happens when we cross this threshold. Now, crossing 1.5 degrees doesn't mean the world instantly ends like in some Hollywood disaster movie, but it absolutely supercharges the risks. Look at this comparison. At 1.5 degrees, coral reefs face severe collapse and heat waves spike. But push that to 2.0 degrees, those coral reefs largely disappear entirely. Heat waves become incredibly common, and millions more people face life-altering sea level rise from melting ice sheets and expanding oceans. The difference is disproportionately brutal. It is literally the difference between severe stress and total system failure. This brings us to a crucial concept, the hidden danger that makes overshooting 1.5 degrees so incredibly perilous: climate tipping points. These are thresholds where, once crossed, climate systems change irreversibly and become self-reinforcing. Basically, once you push a system past its tipping point, it takes on a life of its own. It keeps changing and accelerating, even if we were to magically stop all human emissions tomorrow. Let's ground that abstract science in some terrifying real-world geography. We're talking about the lush Amazon rainforest drying out and shifting into a savanna. We're talking about the long-term, irreversible destabilization of the entire Greenland ice sheet, or permafrost thawing up in the Arctic, which releases massive amounts of methane. And methane, by the way, is a way more potent greenhouse gas than CO2, so that creates a massive vicious cycle. We could even see the disruption of major ocean circulation patterns like the AMOC, which literally regulates the weather across the entire northern hemisphere. These aren't just local problems, they are absolute global game changers. Section 4. Why action fell short. Let's look objectively at the systemic gridlock that got us here. The reasons behind this gridlock form a really complex web. First up, fossil fuel dependency. Let's be real. Our global energy systems are still heavily reliant on oil, coal, and gas. Second, economic and political constraints. Short-term economic goals and, typical election cycles frequently override these long-term climate necessities. Third, there is a profound inequality between nations. Developing nations rightly argue they need economic growth to lift people out of poverty, while developed nations hold the lion's share of historical responsibility for the carbon already up there. And finally, weak enforcement. The Paris Agreement relies entirely on voluntary pledges. These are called NDCs, and there are literally zero penalties if a country just fails to meet them. All right, Section 5, what we can still do. Time to pivot to some constructive strategies. So, scientifically speaking, avoiding 1.5 degrees entirely is becoming pretty unrealistic, unless we factor in a temporary overshoot. Basically, all the current policy models point to this reality. But, and this is key, models do show a strategic pathway forward. Step 1 is acknowledging that temporary overshoot 1.5. Step 2 involves extremely aggressive mitigation paired with carbon dioxide removal, or CDR. Step 3 is using those tools to actively pull temperatures back down for a long-term return below 1.5 degrees. Now, a quick caveat, CDR technologies like direct air capture are super expensive right now and not nearly at the scale we need, but they are going to be a highly critical piece of the long-term puzzle. But look, we absolutely cannot just sit around waiting for future tech to save us. We have actionable strategies we must implement today. We need a massive, rapid transition to renewable energy, solar, wind, battery storage, the whole shebang. We have to electrify our transport and heavy industries. We need strong carbon pricing policies that reflect the true cost of polluting. We've got to drastically plug up those methane leaks. We need to restore natural carbon sinks, our forests and wetlands. And crucially, we need massive investments in climate adaptation infrastructure right now, to protect vulnerable communities from the impacts that are already locked in. This whole situation requires a fundamental reframing of our global climate mission. Because that strict 1.5 degree line is slipping away, the goal isn't just absolute prevention anymore. It is simultaneously about aggressive damage limitation and building resilience. Crossing 1.5 doesn't mean it's game over and we've failed in absolute terms. It means the urgency has shifted. Let me be clear, every single fraction of a degree still matters immensely. And we really have to remember that this isn't just some abstract physical or scientific debate. This is a profound human challenge. It's an ethical challenge. It impacts our mental health, driving very real climate anxiety. It worsens global inequality because the poorest nations almost always bear the brunt of extreme weather. It's already shifting global migration patterns as people are forced to flee unlivable conditions. And above all, it's a matter of intergenerational justice. The younger generations are the ones who will have to live with the consequences of the exact decisions we are making right this very second. It's a huge moral challenge. So, as we wrap up this explainer, I want to leave you with a thought. The big question is no longer, can we absolutely avoid 1.5 degrees? The evidence strongly suggests we're going to cross it. The real, defining question of our time is this: how far beyond 1.5 degrees will we go? And how quickly can we reduce the damage? The future isn't entirely locked in yet. It's still being written by our actions today. Thank you so much for learning with me. I really encourage you to keep exploring, keep asking questions, and let's focus on what we can build next.